Lesson 2.6. Our learning target is I can use a proportion to solve a problem. Our essential question says, how do you write a proportion for a word problem? Our first new vocabulary word is a rate. A rate is a ratio of two measurements that have different units of measure. Units of measure are like the labels. So an example of a rate would be like $5 for 2 burgers. So $5 for 2 burgers. So there's two things that have different units. One is money, one is burgers. A unit rate is the rate for one of something. Because unit means one. So if I use my example from above, if it's $5 for 2 burgers, then it would be $2.50 per burger. So that's for one, the rate for one. A scale and a scale model. So what a scale is a rate that's used to make a scale model. So a scale is a rate used to make a model. Where you see scales commonly would be on maps. So an example of a scale would be like 1 centimeter equals 20 miles. That might be something that you would see on a map. And then a scale model is like a smaller version of something that's really large. So something that's too large or too small, to be convenient to work with. So a scale model is a smaller or larger version of something. So like a blueprint for a house. So architects use a lot of scale models. That's just one example. Okay. Let's see what kind of problems we're going to be solving today. So our first problem is a proportion. What's different about this proportion, though, is that it doesn't just have an x over 14, it's got x minus 2. So we're going to use our cross product method to solve this, but it's going to look a little bit different. So this cross product is saying 7 times x minus 2, like this. And then the other cross product is 14 times 2. So this is what we need to be solving. So we should distribute the 7. So 7 times x is 7x. And then 7 times 2 is 14. And then on the other side, 14 times 2 is 28. So now if I circle my variable, I need to add 14 on both sides. 28 plus 14 is 42. And then if I divide by 7, to 6. My second example says x plus 4 divided by 5 equals 3/8. I'm going to solve it just like that first one. So my first cross product would be 8 times x plus 4. And my second one, 5 times 3. So if I distribute by 8, I get 8x plus 32. And 5 times 3 is 15. Circle the variable. Subtract 32 on both sides. 15 minus 32 is negative 17. Bring down my 8x. And then I would divide by 8 on both sides. And this does not divide evenly, so I am going to leave it negative 17/8. And that's good enough for the answer. Our next proportion, hopefully you can try this one on your own now. Looks like this. Cross products. So the first one, 5 times x plus 3. And then on the other side, 1 times 35. So distribute, and you get 5x plus 15. And 1 times 35 is 35. Circle the variable, subtract 15. 5x is equal to 20 then. And then if I divide by 5, this one divides evenly. So 20 divided by 5, x equals 4. Last one of this type, x minus 3 over 16 equals 3/4. First cross product, 4 times x minus 3, and it equals 16 times 3, which is 48. Distribute the 4, you get 4x minus 12. I circle my x, add 12 on both sides. So 4x equals 60. And last step, divide by 4. 60 divided by 4 is 15. All right, now we're going to switch over to some word problems. On a map of North Carolina, Raleigh and Asheville are about 8 inches apart. If the scale is 1 inch equals 12 miles, how far apart are the cities? Well, the scale is going to tell us one side of our proportion. So 1 inch is the same as 12 miles. Then on the other side of our proportion, I've got 8 inches. They're 8 inches apart. So remember, we need to be consistent. So that means that 8 inches has to be on the top of the proportion so that these labels match. And then on the bottom, I need miles, and that's what we're looking for. So here's the proportion to solve, being consistent on both sides. So 1 over 12 equals 8 over x. 1 times x is equal to the other cross product, 12 times 8. So 1 times x is just 1x. 12 times 8 is 96. So if I divide both sides by 1, that isn't going to change anything. So x equals 96. So 96 miles is how far apart those two cities are. Our next problem says Joel used a gallon of paint to cover 100 28 square feet of wall. He has 932 square feet of wall to paint. How many gallons of paint should he purchase? So on one side of the proportion, I am going to use my rate. So he used 1 gallon of paint. So he used 1 gallon to paint 128 square feet. So 128 square feet was covered by 1 gallon. And then on the other side of my proportion, so I used a gallon, so that means 1, and that many square feet. Here's how many square feet he has. So my 932, being consistent, would have to go on the top this time. And then on the bottom, I put my X gallons. It would not matter at all if I set this up with gallons over square feet on both sides. It's just the consistency piece. The top of the fractions have to have the same label, and the bottoms have to have the same label. So however you set up one side, that controls how you set up the other side of your proportion. All right, so 128 times X equals 1 times 932. So 128X equals 932. Circle my variable, divide by 128. 932 divided by 128 equals 7.28. And that keeps on going. So he would need 8 gallons of paint because you can't buy 7.28 gallons of paint. Now, that was our last example. So you should be able to write a summary explaining how you write a proportion for a word problem.